Now we'll see the applications of logarithms in real life, how scientists use logarithms in calculations, or how different branches of sciences use logarithms in real life. So the first application starts with using logarithms to find the magnitude of the earthquake, which is very important because prediction of the magnitude of earthquake is very important before a major disaster is controlled well in advance. So to start with applications of logarithms, let's start with the first application where I use logarithms in calculating the magnitude. So the first formula is m is log I by s, where m is said to be the magnitude of the earthquake, and then I is said to be the intensity of the earthquake tremor. Of earthquake tremor, and S is said to be the intensity of threshold earthquake. So let's see how we can connect and find the magnitude. So for example, my question is, if the threshold, if the intensity of the earthquake tremor is 10 times the intensity of the threshold earthquake, then I had to find the magnitude of the earthquake. Then find its magnitude. So if I wanted to find the magnitude using the minimum information out here, it clearly says that the intensity of the earthquake tremor is 10 times the intensity of the threshold earthquake. So that I is said to be 10 times of S. As can be clearly seen from this equation, the intensity of threshold earthquake being S, I is 10 times of S. Therefore, when I have the magnitude, which I need to find here, because the question says about finding the magnitude, I clearly have the formula connecting m, I and s. M equal to log I by s to the base 10, of course, the common logarithm. Now this, on simplification, gives me I, when substituted with 10 times of s, gives me 10s by s, so that s gets cancelled both in the numerator and the denominator, and therefore I get this to be log 10 to the base 10, which is 1. Therefore m is 1. That implies my magnitude of the earthquake is said to be 1. The magnitude of the earthquake is 1, is how I understand connecting logarithms with real life. One of the applications of logarithms is connecting the intensity of the earthquake with the magnitude using logarithms. Now let's see the second application of logarithms in real life. As we have seen with magnitude of the earthquake, which can be calculated using logarithms, similarly there's one more application of logarithms in the branch of sciences. So let's see the second application, which connects the pH, which is called the acidity of the solution of the concentrated solution, which can be calculated using logarithms. As you can see in your chemistry class, we all know that the pH is connected with logarithms using the equation pH equal to minus log of H plus, where pH is referred to as the acidity of the solution which is considered in the experiment, and H plus is referred as the hydrogen ion concentration in that particular solution. So this is hydrogen ion concentration in that particular solution. So using this, let's see how we can connect this with real life. So for example, I have an example problem where I calculated if the pH of a tomato, say for example, the pH of a tomato is 4.2, that is the acidity measure for a tomato is estimated to be 4.2, then the question is to find its hydrogen ion concentration. So for the pH of a tomato, which is 4.2, what is its hydrogen ion concentration is the question out here. So this clearly relates that I have to connect with this logarithmic equation where I have the pH of a tomato is given to be 4.2. Clearly, the pH of a tomato is given to be 4.2. And the question is to find the hydrogen ion concentration, which is H plus, is the question. So let's reconsider the logarithmic equation. pH is minus log of H plus, which when substituted respectively for the values gives me pH is 4.2 is negative times of log H plus, so that when I rearrange the terms I get log H plus is negative times 4.2, of course this being to the base 10. Now this is a logarithmic equation which I want to convert to the exponential form. How do I do that? So this can be converted as log a to base b is c. So a is b power c. So this forms as the base of the exponent. So this is the hydrogen ion concentration, which can be calculated using a calculator. So the hydrogen ion concentration of a tomato with its acidity 4.2 is 10 power minus 4.2, as can be calculated using a calculator. Is